All right, so this is an example of binary search. So in this problem, or in this code here, we have an array called scores, and it's populated with some integer values. The key that we're going to be searching for here is 12. And then we have a function here called binary search. And this binary search is going to take two arguments. It's going to take the key, and it's going to take the array name, which is going to be scores. So it's going to look for a function in our code called binary search that takes two arguments. One is the key, and one is the array. So here we've declared three variables: int, low, mid, and high. And we're going to use these as we're searching to find our key that we passed in. So here we initialize low to equal to 0, and then high is going to equal the limit minus 1. Here's our global variable, so it's the length of the array, the number of values in the array, minus 1 for the offset. And then here we're going to do a while loop. And so we'll say low is less than equal to high, and so high is set to 11 minus 1, which is going to give us 10. And while I'm doing this here, as I'm iterating, I'm going to use this chart to help us keep track of how the search is occurring. So we have low, which is at 0, and less than equal to high, which is at 10. Is that a true condition? Yes, it's a true condition. So here we'll go and say 0 plus high, which at this point is 10. So 10 divided by 2 is going to give us 5. And so mid is going to be 5. So here you'll see we have mid set for our first. And then low is at index 0, and high is at 10. So then now we're going to go through our decision making logic. So we'll say if key is equal to scores mid, so it's 12 equal to scores mid, which is going to equal the value of 10, because we plug in 5, and if we plug in 5, index 5, we get 10. Is that a true condition? No, that's not a true condition. So we'll go to our next else if branch, and we'll say is 12 less than scores mid, which is 10, or is 10 in this case greater than 12. That's a fault. That's not true. So we'll skip this branch, and we'll go to our else branch, and we'll say is 12 greater than 10. Yes, that is true. And so at this point here, we'll take mid, which is 5 plus 1, and that'll become our new low. So low is now going to become, just type it in here, it's going to represent the index of 6. And then we'll go back around here, and then we'll occur, this looping structure will iterate again. So now we'll say is low less than equal to high. And so low is 6, and then high is still 10. So we'll plug in here. So 6 plus 10 is 16. So 16 divided by 2 is 8. So now our new mid becomes here. Let me correct this here. All right. So now we're going to go through our decision structure again, and we'll say if 12 is equal to scores mid, in this case is it equal to 14, that's false. And then here we'll go to our branch. So we'll skip the statement here. We'll go to our else if. And so we'll say if 12 less than, or if scores mid, which is 14, is that greater than 12? Yes. So we go into the block here. And so we'll take mid, which is at the value of 8, because of here, right? Minus 1, that gives us 7. So our new high becomes 7, the index of 7. And then we skip out the else, branch, and then we occur again here. So our low still remains the same. So our low is going to be here. And then we'll basically this iteration occur again, right? So now we'll say is low less than equal to high. So low is holding a value of 6, and then is 6 less than or equal to high, which is at 7. That's true. So we'll go into the block here, and then we'll do our calculation. So low is 6 plus high, which is 7. So 6 plus 7 is 12. So 12 divided by 2 is 6. All right, so our mid now is sitting here. So we're just going to do like this. So our mid is 6, and then here we're going to go through the decision structure. So we'll say it's 12 equal to score is mid. So score is mid is holding a value of 11. That's not true. So we'll skip this block, and then we go to our else branch, and we'll say it's 12. If score is mid, which is going to be 11, is that greater than 12? So is 11 greater than 12? That's false. So we'll go here to the else branch. So we'll skip what's on line 10 here. We'll go to the else branch, and then we'll say is 12 greater than score is mid, which is holding the value of 11. That is true. And so now we'll take mid, which is holding a value of 6. So 6 plus 1 is 6 plus 1 is, 7. And so low is now here. All right. And so now we go back up to our iteration. This occurs again. So we'll say, while low, which is 7, is less than or equal to high, is that a true statement? So high is at the value of 7, and because it has the comparison operator of equal, so that is true, right? So 7 is equal to 7. So we go in, and then we'll say, while low and high are both 7, so 7 and 7, 14 divided by 2 is 7. So mid is now here. All right. And then we'll now go through here and make a comparison. So 12 is equal to scores mid, which is 12. That's true, right? So we finally hit our first if condition, and then we return mid. And so mid is holding the index value of 7. So once this function gets done returning, right? So essentially both low, mid, and high are here within this quadrant or this square. So when this returns, it's going to return the value or the index of 7 to our function. So result will hold 7. And so if you can kind of look at what's going on here, we have, so for our first iteration here, we have 0, 5, and 10. And then after that, we have 6, 8, and then 10. And then our next iteration, we changed low, and low was assigned 6. The mid was 6. And then the high was 7. And then the last one here, they were all 7, right? Because they're all in this quadrant here, or the square. So you can think of binary search as it's basically looking for the middle value, and then it's going to pick a side, whether it's to the left or to the right. And then it's going to keep doing that until it finds the index value that you're looking for, right? So that's a short video on binary search. And hopefully this makes sense here in terms of how we actually arrived or use these statements or this logic here to do binary search.